Hi, I'm Dennis Nagel of Cadence Design Systems. Welcome to Sigrity Tech Tips. Today we bring you another installment of how to sign off on your power delivery network design. Our video today will show you how PCB designers are now empowered to establish initial power delivery network constraints without having to become a power integrity expert. Utilizing Allegro Sigrity power integrity technology, PCB designers can now use automated IPC calculations to establish targets for their power delivery network design. No longer will PCB designers either have to wait for power integrity experts to establish constraints for them or be faced with starting their designs with no guidelines. Instead, with IPC calculations built into the design and analysis environment, first-order constraints can be easily developed and verified with integrated IR drop analysis by the PCB designer. When more detailed design requirements come later in the process from the PI expert, design rework will surely be minimized. With the comprehensive Sigrity PCB power integrity solution, your PCB design team will be able to accelerate the design cycle, ensuring your product will meet the time-to-market objectives and making the whole team look good at the same time. You might just be recognized by your management as the superstar design team in your company. In today's video, you will see us utilize the Allegro Sigrity PI base and PI sign-off and optimization option. To learn more about these products, visit us at www.cadence.com. Now I will turn it over to my colleague.
Today, we're going to look at a demo of IPC-based automated constraint management configuration with Sigrity Power DC technology. There are three ways to set up DC constraints in Power DC. You could manually enter constraints, automatically generate constraints using IPC standards, or you could reuse constraints from before that you've saved as an Excel spreadsheet. Using IPC standards, starting with just an allowed temperature rise, you can generate via, plane, and trace constraints. For each type of object, we have global constraints set for worst case value, the most restricted your constraints could need to be. But you can override global constraints for each instance to avoid wasting time and resources meeting what are overly restrictive constraints for some situations. Let's look at a demo of IPC automated constraint management in Power DC. Here, you can see the three constraint modes. We're going to use IPC standards to automatically generate constraints based on allowed temperature rise, which is the third option here. You can check the global via current and via current density constraints and individual constraints. The same for planes and traces. So let's say the allowed temperature rise is 60 degrees. Just change the value and the constraints are automatically calculated. Global constraints for via current and via current density are here. Again, it's the same for planes and traces. You can also add individual objects, like a trace. Simply select some traces and add them to the list, and you'll be able to manage the constraints for each individual object. This feature is available in both standalone Power DC and Allegro PI base. That means PCB designers can quickly find and easily fix common power problems in their layout. Looking at our example, we see some violations in the simulation results. But looking more closely, we can see the actual current density and the maximum density for specific traces. And remember, this is calculated based on IPC standards. By confirming the maximum current density, we can pinpoint which traces are causing the violation. Editing the trace is easy. In Allegro, all the PCB designer needs to do is select the trace and change the width. Let's try changing the width from 8 to 20. Back in Power DC, select the net we just changed and update it. You can see the traces have changed, and from the Constraints pane, we see the constraints still apply just like before. So let's rerun the simulation and see how it looks. And it's done. So looking at the results, we no longer see any violations. Our simple fix worked, and it was easy for the PCB designer to implement. The PCB designer can verify it's fixed for themselves too. Looking more closely at the physical design in Allegro, you'll notice there are no DRC violation markers for the traces. From the Analyze menu, the PCB designer can select DC violation markers and confirm that there are in fact no specific trace current density violations. However, there are of course other violations that can be displayed. Standards are great because they make it easy for anyone to follow rules without having to worry about the theory behind them. Designers just need to input the allowed temperature rise, and global constraints are calculated using IPC standards. Those constraints are for worst-case scenarios, so you can override the global constraints for any specific instance where it's okay to be less restrictive. And you can save these constraints as an Excel file to make it easy to reuse the exact same constraints again. What's really great is all of these functions are integrated with Allegro PI Base, so the PCB designer can do a lot of this on their own. That really speeds up the design cycle by saving one or more iterations that used to have to go back and forth between the board designer and the power engineer. Now back to Dennis.
Thank you for watching another edition of Sigrity Tech Tips. For information on products used in today's video, click on the links below or contact your local Cadence sales representative or Cadence channel partner.